Okay, thank you very much for joining to today's session. So today we've come to third tutorial where we're going to understand the simple entity relationship model. So this is our Unit 6 organizational data architecture, and what we've covered so far in our previous tutorials, we've introduced and explained the principles of organizational data architecture. So in our learning outcome, we looked into explaining the importance of data as a business resource. Then we went in and described the differences between operational system and analytical system. And in our second tutorial, we now looked into understanding the life cycle of our data architecture. We looked into from the initial phase where we had our business understanding all the way through our deployment phase. So we covered the full life cycle stages and looked into them one by one. So obviously we described the importance of databases in our first tutorial, where we looked into different type of databases and how these interact and communicate with each other, and how our business benefit from these solutions. So in today's session, we now circling back to our database, and we'll look into entity relationship model, which is a concept that we're already familiar with, and now we need to apply to data architecture. So let's now get into our presentation. Okay. So what are going to be our indicative content from today's session? We're now going to look at entity relationship models. So we're now going to look into the concept of these models and how they now apply within database system management. So we'll also cover topics such as entity, attributes, and everything we need to know when it comes to designing database. So what is an entity? Basically, an entity can be seen as an individual, such as, for example, a person. Person could be an entity. So as the definition says, this entity can be a distinct object or concept in a database, and this which can be identified. And attributes are simply going to be some quality that we can find in our entities. So, for example, if we look in our car, attributes could be steering wheel, tires, wheels, and so on. So, as definition says, attributes are properties or characteristic of our entity. So each attribute holds a specific piece of information about our entity. So database management system, a really important concept which we need to understand, are relationships. So where we need to understand how tables can now relate to each other. So as definition said, relationships describe how entities interact with each other. So they define the association between entities. Types are common relationship types, including one-to-one, one-to-many, and many-to-many. So when it comes to interact with our tables, we need to identify which type of interaction we're having in order for us to create our EFD diagram. Also, a very important concept is to understand what primary keys are. So primary keys are a unique identifier for entity. So by having this primary key, this unique value, we know that this is not going to repeat with other tables. So it's a unique value that makes it, let's say, special. So for example, student ID might be our primary key for our student entities. Foreign keys are simply attribute in one entity that links to our primary key of another entity. So let's give you an example. When in an enrollment, entity that represent the relationship between student and courses, student ID, courses ID, would be a foreign key linking to the his respective primary key. So we normally use our student management system as an example. So here we have an example where we have entity and attributes. So we can now present our primary key, which is our student ID, and this primary key has these entities now have the various attributes. So for students, we can see name, date of birth, email. Like courses, we have course name and credit. So the same process apply for instructor, tutor, and enrollment. So we spoke about relationship types. So student to enrollment, this can be one-to-many, depending on circumstances. Courses to enrollment could be one-to-many. Instructor to course could be one-to-many. Diagram. So when it comes to diagram, we can now have a simple textual representation, which is now illustrated below. So in our diagram, we saw that our student entity have its own attributes, the primary key and the other attributes. Same concept for course entity, instructor entity, and enrollment entity. So we now know that enrollment entity captures the many-to-many relationship between student and courses entity. When we can see that each record in the enrollment links a student to a specific course and is now representing a single enrollment instance. So now we're going to explain what is the difference between type and instance. So as the definition says, with data modeling and object-oriented designing, concept of type and instance are now going to be fundamental when we know that type are going to be our way we have our relationships. While when it comes to our instance. We'll now be using them when it comes to popular unified modeling languages. So definition for type is a context of data modeling and object oriented design, where we're now going to refer to our blueprint of template that define the structure of having object. So for instance, our type could be a class, and in this class, we're now going to add our attributes, method, and static structure. So what are the again, as I said, the characteristic of our class are going to be attributes, where we're now going to define a set of attributes, for example, for our class. Method, where we're now going to declare operations and functions. And then static structure, we're now going to represent a static system, specify from the kind of data object which is going to handle these operations. So it's pretty much the same concept of programming when we have our class, and in our class we're now going to have our attributes. In object-oriented programming, simply going to be parameters, our parameters, and then we now have methods. So here we have an example where we're going to consider class diagram for a student. Instance. So basically with instance, we're now going to refer to the concrete appearance of type. So in other words, it's a specific realization of our class. The characteristic of our instance, specific data, dynamic, and uniqueness. So with the specific data, instances contain specific data that correspond to the attributes defined by the type. When it comes to dynamic, our instance will now represent the dynamic aspect of the system. And uniqueness, where each instance has a unique identity. Here we have an example where we're now going to use our student class. An instance will be our actual student object. UML. So when it comes to a UML class diagram, this is simply our graphical representation of our class, where we're now going to see all the relationship in the system. The component of our UML are going to be classes, relationship, and relationships. Here is an example of how our UML class diagram will now be represented. So alternative UMLs are bankers and IDEF 1x. So with bankers notation, we now have entity types, relationship, and relationship, where by having this entity type, these are very much similar to our UML classes, and they're basically going to represent our entities and attributes, while relationships are going to, again, outline the cardinality indicators. IDEF 1x notation again, pretty much has the same concept of having entities and attributes, which are now going to similar to our UML classes, but they're now more focused on database design. Attributes are now detailed within entities, emphasize data, control scheme, and relationship. So now we're going to identify types and the attributes. So we've explained that when we have our ER models, we now have the primary component and entities, relationship, and the attributes. So what happens now is that with our component, they're now used to structure and define the data within our database systematically. So with our entities type, we're now going to represent distinct object, or for instance, concept within our database. So as notation, our entities are now going to usually going to have rectangles in our ERB diagram. So here's an example of how our school database will now have the entities included, where each entity type will now have its own attributes, which is going to now describe them. Attributes, again, these are going to be type, name, and value, where we now know that attributes are quality. These are qualities or properties related to specific component of our entities. So the types of attributes that we have are simple attributes, composite attribute, derived attribute, and multi-value attribute. So examples for this are going to be student entity attributes. For a student entity, attributes can now include student ID, name, date of birth, email, age, and phone number. When it comes to relationship, we now know that we have type, cardinality, row description, direction, and mission, where the relationship is now going to illustrate how entities interact with each other and how this is going to define the association between entity types. So what are going to be relationship types: one-to-one, one-to-many, and many-to-many. So by cardinality, we're now going to define the number of instances of our entity that can now be associated with each instance of another entity. Notations is now basically going to look into the relationship that are now represented by diamonds or line connecting each entity rectangles. Here we have more example of how our notation is going to work. For instance, when we are connecting student rows in the course, we are going to use a many-to-many relationship, and they will now have their own type of notation. Or for instance, instructor teaches courses, which is a one-to-many. So again, we have an example of EFD diagram with notations, where we've been given our entity and relationship. And we also now have our attributes. Now we're going to identify a relationship between type and the cardinality. So in the entity relationship model, we now have to define how entities are going to interact with each other. So that's where cardinality comes into place. And this is very crucial for the accuracy when representing the data and business logic. So what are going to be the key component cardinality? We're now going to look into entity and relationship or cardinality, operation signature, and business relationship. So with entities and attributes, we now have to identify our main entities and then attributes in the school database. So our entities are going to be student, courses, instructor, and enrollment. Each of them will now have their own attributes. So student ID, name, date of birth, course ID, course name, instructor ID, name, department, and enrollment ID and student ID. So what is the relationship and cardinality here? So we now know that we have a relationship between student enrolls in the course. We now know that the type is many to many. So the cardinality that we now presented with is that student can enroll in multiple courses and course can have multiple student enroll. So looking at the attributes, known directly for the known directly for the relationship, but the enrollment entity captures the association. So again, we have instructor teaches courses. What type of relationship this is a one-to-many. The cardinality presented here is that an instructor can teach multiple courses, but each course is taught by one instructor at a time. Attributes here, none of them directly for this relationship. Operational signature. So with this concept, we're now going to define our methods, which are going to be now associated with entities. And we're now going to include parameters and the return type that we get from these methods. So examples of operation signature. We have student entity. We have a row, which has to be integer type of value, a data type, and it's going to return a Boolean, which is yes or no. Operational name, a row, parameters, course ID, which is integer, and we return our return type again is a Boolean, where we're going to check if it's true or false. Structure entity, instructor entity. Again, assign colors. Check if this statement is true or false. Operations name. Then we now have parameters which will be added as integer, and our return type again is a boolean. So by description, we're now going to assign the instructor to a specific course. I'm going to return true if successful. So our business relationship described by an entity relationship diagram. So with our ERD, we can now visually represent the relationship, the business relationship between the entities. So this is more visual and allows us to see how our business operates. So let's have an example where we now consider a simplified textual representation of ER diagram for a school database. So we can see that this is coded with PHP. We now have our entities included, our relationship, and our operation signature. So our graphical representation, our diagram, graphical representation of our UML will now be added as follows. So we now come to our distinction activity. We're now going to evaluate the importance of understanding the direction of relationship and how this impacted the navigability between types. So what do we mean by evaluating and understanding the direction of relationship? So we now see that when we have ER diagram models or unified modeling languages classes, these are now essential for accurately modeling the interaction between different relationship types, so between different entities or classes. So by having the direction of a relationship well defined on how entities are connected and how they navigate between each other, we now are going to significantly implicate on how data retrieve our system design and have an overall better understanding of our functionalities. So the key aspect of our relationship directions are going to be definition of the directionally, impact of navigability, implication for system design, and also lastly we're going to have examples of ER and UML diagrams. So when it comes to relationship directionality, this could be unidirectional or bidirectional. So with the unidirectional, we now know that a relationship where navigation is possible in only one direction is called unidirectional. So for instance, when a student enrolls in a course, but the system only needs to know which course a student is enrolled. And basically this relationship might be unidirectional for the student to the course. With the bidirectional, this is when navigation is possible in both directions. So unlikely from our first example, the system need to know both which students are enrolled in a course and which course the student is enrolled in. So this goes both ways. It's important also to know the impact of on navigability, where we have unidirectional navigability and bidirectional navigability, where with the first one entity is aware of the other, but not vice versa. So this can simplify data models and reduce complexity, but at the same time, it's going to now limit our functionality in a certain scenario. With bidirectional navigability, both entities are aware of each other, and they're now enabling our full navigation in both directions. So why is this important? This allows us to have data retrieval, system design, and this is going to improve our performance. Implication for system design with when having data integrity and consistency with our data architecture. This can now, with our system design, this can now have unidirectional, bidirectional, where with the unidirectional, it's not going to be easy to maintain as only one entity needs to be updated during the changes. While with a bidirectional, we now require a more solid mechanism to ensure that integrity and consistency stays intact across both entities involved in our relationship. Flexibility and scalability are another important aspect, where with the unidirectional model, this might be more scalable and easier to manage, but might require to redesign if the business requirements are changing. While with the bidirectional, this offers now better flexibility and allows us to change quickly due to the business needs. So examples of business context would be customer and orders when it comes to dealing with our customers and orders. So for instance, our diagram, when is unidirectional, we now have a system where only orders need to have a reference to the customer, while with the bidirectional, we now have a customer relationship management system where both customers and orders need to reference each other. Employee and department as well is important because department now refers to its employees, but not vice versa. While with the bidirectional, both employees and department will now refer to each other. And here we do have an example of how the entity relationship and UML diagram relate to each other. So to now conclude, understanding the direction of relationship in data models is now essential for effective database and system design, where we now know that relationship direction and impact, navigability, data retrieval, system complexity, and performance. So this was everything for today's session. Any question for me?
Thanks, Victor. No, that was all pretty clear. No questions for now. But obviously, if I do think of anything, I'll drop you an email.
Okay, that would be great. Thank you for that. If there's any question, we can now jump on our final discussion session.
Cool. See you in there.
Okay, I'll see you there. Thank you.